Today we're starting a new topic. We're going to start talking about graphs, how our variables are related. And this kind of coincides with our from section 4-1, using graphs to relate to quantities. Now to start, something that we need to be familiar with. The term variable. A variable, it's a symbol, usually a letter, doesn't necessarily have to be a letter, but usually it is, that represents one or more numbers. So it can represent one number or an infinite amount of numbers, or numbers from 10 to 20, or any increments. So it represents a certain amount. Now remember, when we're graphing, we're going to be looking at a lot of graphs today. The first thing to think about, and we're going to only be worrying about kind of one quadrant of the graph, the first quadrant. Remember, what goes across the bottom is our x variable, and what goes across the top is our y variable. Every single time. And you always want to read a graph like you're reading a book. As you go from this way, going to the right, going left to right, we're always going to express it as, start off as x increases, or whatever the variable is. As x increases, y is going to do something else. Or as time increases, the amount of sales increase. Or as time increases, something decreases. So we're going to be using words like increases and decreases, constant, things are growing constantly, growing faster or slower, and looking at graphs. But we're always going to start it as x increases. So if we look at a couple of our graphs that are given in your notes, one kind of looks like this. So we could say as x increases, y increases slowly, then it increases really fast, and then it increases slowly again. So here's the part where it's increasing slowly. It's only going up that much. But if we use the same distance here, look how much more it grew there. So it grew slow, and then it grew fast. The second graph kind of looks like this. Right? You can see as x increases, the y value decreases a little, then it decreases a lot, and then it decreases only a little. Again, as your x increases. Here's another one. As x increases, you can describe this as y increases and then decreases. So as x increases going left to right, the y value increases and then it decreases. And then the last one, the little graph, there's just a bunch of points. And I don't see a relation here. I don't know if you can see that one. Okay, there's just a bunch of points here. So that last one, that graph that looks like this, there's no relationship. There's no relation there. All right? So a lot of things can be described using a graph. So if we look at example 1, okay, go ahead, and it says, the graph shows the volume of air in a balloon as you blow it up until it pops. Describe how the variables are related at the various points. And it shows the different graph. So here it is. So you can see it starts at 0, it grows, then it flattens out. It grows, flattens out, grows, flattens out, grows, and then goes all the way down. Then it goes all the way down here. Now, the first thing it says is we need to describe the variables. So our x variable is time, our y variable is volume. So as time increases, the volume changes. So I got a balloon. kind of demonstrate what's going on here. So, if we look at the first, let me show you up here so you can see it. So from our graph, it goes up, flattens out. Up, flattens out. How many times does it do it? Up, flattens out, up, and then it pops. So, here we go. I stop. As time goes, the volume's not growing anymore. Here's my second one. I take a breath. I take a breath. And it popped. So that popping sound almost instantaneously dropped it here. So you can see this is kind of divvied up into different regions. Let's say we have A, B, C, D, E, F, G, and then our line going straight down is H. So where is our volume growing? We could ask. Our volume is growing at sections A, C, E, and G. These points here. Where the volume is constant. Okay? And let's talk about the word constant. Constant. Does not change. Very few things in the world are constant. But in math, we try to make them constant. So here the constant is B, D, and F. There's no growth to the volume. It's staying level. So we can describe this as volume, or as, remember, time is here. Volume is our Y variable. So we can describe this as time increases. Again, it's always going to be as our X value increases every single time. Right. Volume increases, and I'm going to abbreviate here. Increases, stays the same. Increases, stays the same. Increases, stays the same, increases, and then the balloon pops, and volume goes to 0. Right where it started, an empty balloon. Because again, it just popped. So looking at example 2 here. A research studied the effects of sleep on students before a test. Concludes that the more sleep a student gains the night before a test, the higher the student's test score. So here's the graph. So we're comparing sleep, which is our X variable, and our test score is the Y variable. So I kind of did a little sketch here. So our two variables are sleep and test score. So we're answering this question. And everyone's graph can be different. But I would assume even with 0 sleep, you'll still get some kind of a test score. But the more sleep you get, it's going to kind of go up, go up, go up until a certain point. Then it's going to kind of stay flat or stay constant. So whether you have 7 hours of sleep or 8 hours of sleep or 12 hours of sleep, your test score is not going to have any change there. Okay? So I want to look at letter B here on this one. It says, what are the variables in each graph and describe how the variables are related at different points. So we can see there are variables are minutes of calls, and the cost. So we could describe this one as the minutes increase. I'll start writing that here. You can fill that in. Again, our x variable will always be increases. So, as minutes increase, what's happening with the cost? Is there growth? Is it increasing or decreasing, or is it constant? We could say that it's constant. See, as the minutes increase, the cost remains constant. And then increases. There's two parts to our graph. You can see it. It's constant, and then it increases. So this would be the answer for where it says, got it, letter B. Don't worry about A. Okay. So now we want to look at page 2 on example 3. We want to look at how the graphs are represented. So it's given us a chart. It tells us day 1, day 2, day 3, day 4. The days and total downloads. So it's like a band allowed fans to download its new video from the website. And here's the table. So after one day, there were 346 downloads. Day 2, there was 1,011 downloads. Day 3, 3,455 downloads. And day 4, 10,426 downloads. Now we want to match the graph with this table. Is it A, B, C, or D? Now we can see that the days is one variable and the total downloads is the Y variable. So if I'm graphing this, here's day 1, day 2, day 3, day 4. These are in thousands. Maybe I go 1,000, 2,000, 3,000, 4,000, and so forth. We want to plot these points. 1 and 346. Again, this is guessing. It's about there. Day 2, it's right about 1,000. Day 3, it's a little over 3,000. And day 4, we're at 10. There's 5, 6. It might be way up here. So you can see that this graph kind of looks like that. Which one does it match up with? A goes up like a line. B kind of takes that shape. C kind of going the other way and flattens out, which it's not doing. And D, it's actually going down. So the answer here would be B, this one right here. Now I want to look at this last one. So the example number 4, we have CDs purchased, and we have the total cost. So here's my two variables. So if one CD is purchased, make $15, then $30, then $45, $60, and $75. If we were graphing this,